Okay, this video is going to cover how to find the determinant of a 3 by 3 matrix. I'm going to show two different methods in this video. One method, the first method I show, will be the method that I showed in class. It doesn't matter to me which one of these methods you use. However, the one we covered in class is the one we'll have the most practice with, so it is the one that I recommend. Either method will work every single time. So the method that we use, that we used in class, is called the diagonal method, or at least I've been calling it the diagonal method the whole time I've been teaching. Essentially what we do is we copy the first two columns, so 3, 4, 2. If I can get my pen to behave. There we go. And 2, -1, 5. Then we're going to go in and we're going to find there are three positive diagonal products that we need to do. So we're going to multiply the numbers along each of the three positive diagonals. So these three are going to be positive products. So what I'm saying there is we're going to multiply those numbers together. 3 times -1 times 1 plus 2 times 3 times 2 plus -5 times 4 times 5. And then to that, we are going to combine that with the products of the negative diagonals. There are three of those as well. So these three upward diagonals are called the negative diagonals. So we're going to go minus, and then these three numbers, 2 times -1 times -5. Minus 5 times 3 times 3, minus 1 times 4 times 2. And we're just basically going to put that in and simplify that down to a single number. So that would be -3 plus 12 minus 100 minus 10 minus 45 minus 8. And we're simply going to add all those numbers together, which will give us the determinant of this 3 by 3 matrix as being -154. So let's do another example of this. Here is a second matrix. We're going to do the same thing. Oops, too far. We are going to we're going to duplicate the first two columns, 7, 3, 2, -2, 5, 1. Then we're going to grab our three positive diagonals. That is 7 times 5 times 5 plus -2 times 3 times 2 plus 0 times 3 times 1. Then we grab our three negative diagonals. That's -2 times 5 times 0 minus, and that's not really -2, it's minus 2 times 5 times 0. So 2 times 5 times 0. Minus 1 times 3 times 7. Minus 5 times 3 times -2. And we, once again, are going to simplify that down to one number. So 7 times 5 times 5 is 175. Minus 12 plus 0 plus 0. Could write minus 0 if you prefer, it doesn't matter. Minus 21 and then plus 30. Again, we're going to feed those numbers to a calculator, make sure we get it right, because this is a very tedious thing. If we're not careful with our details, we will end up making silly mistakes that we really don't need to make. So our determinant for this 3 by 3 matrix would be 172. Now, determinants have a lot of applications, but again, we can't really talk about those applications until we understand how to find the determinant. So hopefully that method works for you, in which case you can stop watching this video. I, however, am going to be resetting these problems And I am going to make sure I don't make any mistakes. I'm going to just write the answer in the upper right-hand corner of each screen as I go. Because I want to make sure that I get the right answer as I do this second approach, which I generally do not do. I don't generally teach this second method. The second method is called expansion by minors. Now, what this deals with is it breaks down the same sort of thing we just did, except it breaks it down into 3 2x2 matrices to find the determinant of. And if you watched the previous video, you know that finding the determinant of a 2x2 matrix is much simpler than finding the determinant of a 3x3 matrix. So what we do is we work our way across the top row. We start off with that top left entry, 3. And we say, okay, 3 is in the top left. So if I block the first row and the first column, that is the row and the column that 3 is in, I'm left with a 2x2 matrix. So I'm going to multiply 3 by the determinant of that 2x2 matrix, which would be the matrix -1, 3, 5, 1. Now, I then am going to move to the next element in the top row, which is -2. And I also need to switch my signs. So now I'm going to go minus, and I'm going to put this 2 down. Well, the 2 is located in the first row, so that gets blocked, and the second column, so that gets blocked. And if we look, the remaining entries in the 3x3 form a 2x2 matrix, so I'm going to multiply that by the 2x2 matrix, 4, 3, 2, 1. Then I switch my sign again and go back to positive, and I go to the last entry, which is -5 in the first row. And once again, I block the row and the column that -5 appears in, which creates a 2x2 matrix for -1, 2, 5. So now what I'm going to do is go in and do these multiple mini problems. There's 3 smaller determinants now that I need to do. So I have 3 times, and then I do that matrix, which would be -1 times 1 minus 5 times 3. -2 times 4 times 1 minus 2 times 3. And then I'm going to go ahead and combine this into a -5 times 4 times 5 minus 2 times -1. Now, if you're not familiar with what I'm doing, you need to go back and watch the 2x2 determinant video, because that's what I just did. A times D minus C times B for each of these 3 problems. So that's 3 times, and I'm going to simplify this down to one number. That is -1 minus 15, or -16, minus 2 times 4 minus 6 is -2, minus 5 times 20 plus 2, or 22. So that's -48 plus 4 minus 110. So hopefully I got that right this time, because I've already messed this video up once, and that was kind of annoying. That equals the same answer as we got before, so thank God I did it right this time. -154. So let's repeat those steps on one more example so that you can see it work. Let me get this out of the way here so that I can leave this in a decent path. There we go. Okay. So here we have another 3x3 matrix. We do already know the determinant, but we're going to do it again anyway. Again, we're going to start off positive, and we're going to say, okay, 7 times. And we're going to go in here and we're going to block off the row and the column that contains 7 to create the 2x2 matrix, 5, 3, 1, 5. Then we switch our signs and we say minus, move these boxes out of the way so we can see what we're doing, and we enter that next number, which is -2, times, and we go in and we block off the row and the column that negative 2 is in the first row, leaving us with 3, 3, 2, 5. Grab those boxes, get them out of the way, and we do our last entry. So we say plus 0 times, and anybody that knows the properties of 0 knows that we can't screw this up as long as we do our multiplication right. But again, the process is what's important here, so we're going to go ahead and block that row and that column, and that will give us the numbers 3, 5, 2, 1. So then we're going to go in here and we are going to do each of these determinants separately and narrow this down to one number. So that's 7 times 5 times 5 minus 1 times 3 plus 2 times 3 times 5 minus 2 times 3 plus 0 times, and it doesn't matter if we screw this up or not because it's going to go away when we multiply it by 0 anyway. So that would be 7 times 25 minus 3, which is 22, plus 2 times 15 minus 6, which is 9, plus 0 times, and again it doesn't matter if we screw this up, 3 minus 10 is negative 7. So that would be 154 plus 18 plus 0, or the same answer we got with the other method, 172. Does not matter at all to me which one of these methods you use, whether you choose the diagonal method or the expansion by minors method, but I would highly suggest, given modern technology and the fact that you're never going to have to do one of these that's bigger than 3 by 3 by hand, even when you get to college, that you go ahead and stick with the one we did in class, the diagonal method. If you'd rather do expansion by minors, go ahead. I'm more than capable of grading it that way.